Imagine a place so dry that some areas haven't seen rain for centuries. A place where the air is so thin, it feels like another world. Now, at the heart of this bleak desert, there lies one of humanity's greatest achievements, a technological marvel designed to unlock the secrets of the universe. ALMA, the Atacama Large Millimeter-to-Millimeter Array, or, in short, the world's largest and most advanced telescope in Chile, stands tall in the Atacama Desert. It is not a telescope, but rather it's a window into the very distant past that allows us to explore origins and where stars, planets, and galaxies were born. So, let's roll with why this telescope was built, how it works, and why the Atacama Desert is the perfect spot for this groundbreaking science. The Atacama Desert is one of the driest places on Earth, with some parts receiving less than 1 millimeter a year. But why is dryness important to astronomy? ALMA observes the universe in millimeter and submillimeter wavelengths. Those particular wavelengths are absorbed by water vapor in the atmosphere. Thus, the dry air at Atacama ensures that there's minimal interference so that faint signals coming from space would be captured by ALMA. In addition, the fact that the installation of the telescope sits at about 5,000 meters above sea level at the Chajunta Plateau cuts down distortion, since atmospheric conditions thin it out majorly. This also helps the sky have a pretty clear view of things. For example, the observatory in question can be placed half the height of Mount Everest. Lastly, the desert has the benefit of being remote. This leads to virtually no light pollution. This is very critical since even the smallest quantities of artificial light can interfere with the data collection. ALMA is not one telescope but an array of 66 high-precision antennas of diameters ranging from 7 meters to 12 meters. All are used in tandem by some concept called interferometry. Instead of one single, really enormous telescope, ALMA assembles signals from all 66 antennas to be fed into a virtual telescope up to 16 kilometers in diameter. Such spectacular resolution, they can identify an object the size of a golf ball at a distance of 15 kilometers. Building ALMA was a huge international collaboration. It will cost around $1.4 billion USD and is a project of the European Southern Observatory in cooperation with the National Science Foundation of the USA and institutes from Japan and East Asia. ALMA will explore the cold universe. This includes dust and gas clouds, where the stars and planets are born, far-off galaxies, in an effort to understand how these would have formed millions and billions of years ago, and molecules in space, even detecting signs of life. Since its inauguration in 2013, ALMA has revolutionized our understanding of the cosmos. ALMA directly imaged the formation of a planet around a distant star called the PDS-70 system. For the first time, the birth of a planet was caught by humanity. The work also led toward the famous Event Horizon Telescope project that released the first ever picture of a black hole in the galaxy M87. Water was found by ALMA within a galaxy that existed just 1.4 billion years after the Big Bang in 2021. And just as this makes us a little wiser about how critical ingredients for life are distributed in the cosmos, some of the most beautiful images of protoplanetary disks, the nurseries of planets, have been captured by ALMA. Such images contain intricate details, such as gaps where planets might be forming. Operating such a high-end telescope in one of the most inhospitable sites on Earth brings its own set of problems. Oxygen levels at 5,000 meters are 50% less than at sea level. People working on-site, engineers and scientists, have to work with supplemental oxygen and constant health monitoring. The antennas are extremely sensitive and therefore have to be calibrated constantly. Dust and temperature variations also present significant challenges. ALMA produces way over 2 terabytes of data every day. That quantity must be processed and stored efficiently, and it requires the highest computational power. Why ALMA? It is not only scientific discoveries, it is humankind reaching out to understand the universe and the place of human beings in the universe. It stands as a shining example of what the world can do when nations come together. It united scientists, engineers, and funding from all the corners of the continents. ALMA techniques have more applications. It serves as satellites that will enhance communication and image technologies. Projects like ALMA challenge young minds to apply their strengths in science, technology, engineering, and mathematics careers. They remind us that the universe is vast, mysterious, and full of opportunities for exploration. ALMA is much more than a telescope. It paints pictures of the universe in its most distant, hidden abodes, from the first light of stars and planets to the hidden worlds of galaxies. It's helping propel us towards some of the greatest questions. Where do we come from? Are we alone? And what lies beyond our reach? I look out at this night sky and realize how here in this far removed desert there is a human marvel of ingenuity unraveling some of the darkest mysteries of the cosmos. Let me know your comments on this amazing telescope. Like and share. Subscribe.